erosion. History of soil. In the beginning, the Earth's crust was made up of thick layers of rocks. These rocks were continually heated up by the sun and cooled by the rain. The wind, water, heat, and the cold helped these rocks to crack and break into smaller pieces. Now, this breaking up of the rocks went on continuously for years. After thousands of years, very fine sand, pebbles, and gravel were formed. These, together with the remains of dead plants and animals, make up the soil that we have today. The topmost layer of the Earth's crust forms the soil. Importance of soil. Indirectly or directly, life on Earth depends on soil. Let us see how. Soil provides a medium for the growth of plants by fixing the roots in it. It provides optimum conditions of water, temperature, air, and nutrients for the proper growth of plants. Foods like cereals, pulses, fruits, and vegetables are obtained directly from plants grown in the soil. The animals that provide us milk and meat feed on grass and plants that grow in the soil. Soil provides shelter to many burrowing animals like moles and earthworms. These animals loosen the soil to facilitate aeration. Soil is a rich source of iron and aluminium used in industries. Soil formation. How is soil formed? Soil is formed by the breaking up of rocks. The Earth is made up of different kinds of rocks. Now, by the action of the sun, the wind, and the rain, these rocks break into small pieces. The acids produced by the roots of plants that grow in the cracks of the rocks also help to break up the rocks. These pieces of rocks are carried to other places by running water, moving ice, and strong winds. In this way, rocks break to form soil. Each kind of rock gives its own type of soil particles or grains. So the kind of soil depends upon the kind of rock from which it is formed. Stages in soil formation. Stage 1. As a result of weathering, bare rock begins to break up near the surface. Weathering is caused by the action of frost, chemicals, and temperature. Stage 2. After weathering, an organic layer develops. Bacteria and fungi act on the remains of plants and other organic material, forming humus. Stage 3. In the last stage, the soil is formed by the action of percolating water. Layers of soil. Soil is found in layers. Don't believe me? Well, let us see for ourselves. Go to the garden and study the top layers of the soil. Pick up some of it in your hand and feel the grains. You will find the soil to be loose and there may be roots of plants and grass in it. Is it not so? Now this is called the topsoil. We find plants growing mostly in the topsoil. Take a spade and dig a little deeper. You will find closely packed soil with some pieces of rock. This layer is harder and is called the subsoil. If you dig still further, you will come to the solid rock from which subsoil is formed. Soil profile. Soil is composed of distinct layers. Perform the following activity to find out how these layers are arranged. Take a little soil. Break the clumps with your hand to powder it. Now, take a glass tumbler, 3/4 filled with water, and then add a handful of soil to it. Stir it well with a stick to dissolve the soil. Now let it stand undisturbed for some time. Afterwards, observe it and answer the following questions. Do you see layers of particles of different sizes in the glass tumbler? Draw a diagram showing these layers. Are there some dead, rotting leaves or animal remains floating on water? The rotting dead matter in the soil is called humus. A. Horizon. The uppermost layer of the soil is called the topsoil or A. Horizon. It is usually darkest in color due to the presence of humus. Humus consists of dead and decomposed remains of plants and animals. It is this layer that makes the soil fertile. It enriches the soil with organic matter and also contains the roots of plants. Many living organisms are also found in this layer. The soil here is soft and porous and has a large water holding capacity. Plants absorb the nutrients required for their growth from this layer. B. Horizon. This layer lies below the topsoil and is comparatively lighter in color. Subsoil is not as rich in humus as the topsoil. It contains large amounts of iron oxides, aluminium, and soluble minerals. Due to the presence of these minerals, it is red or grey in color. It mostly contains sand, silt, clay, and some stones. Rainwater collects in this layer. Few plants or trees have roots long enough to reach this layer. Very little organic matter is present in this horizon. Hence, it is not suitable for plant growth. C. Horizon. It is the bottommost layer of soil and is called sea horizon or parent rock. It is made up of incompletely weathered rocks and stones with cracks and crevices. It is completely lacking in organic matter, but some minerals are found in this layer. The weathering of the rock pieces in the sea horizon leads to the formation of soil. Now below this layer lies the layer of large solid rocks called the bedrock or D-horizon. It is the non-porous, that is, impermeable layer, and rainwater collects over it to form the water table. It forms the base of the soil profile. To study the soil profile, with the help of a spade, dig a deep pit in an open field. Carefully note the changes in the color and rock sizes as you dig deeper. The change in color and rock sizes indicates the A, B, and C horizons. Components of soil. Rock particles. Rock particles influence the properties of soil. Depending on their size, the rock particles are divided into 4 groups. Clay particles are the finest rock particles. These are tightly packed together. Therefore, very little air is present between clay particles. The tiny gaps between these particles are occupied by water. Silt particles are a little larger than clay particles. These are not as smooth as clay particles. Sand particles are larger than silt particles. Since sand particles are quite large, they are held loosely and there are lots of empty spaces between them. These spaces are filled with air and allow water to drain out quickly. Gravel particles are the largest rock particles. Humus. The organic matter like dead and decaying remains of plants and animals present in the soil is called humus. Humus is the darkest layer of the soil. It is most important for plant growth because it makes the soil fertile. It contains all the nutrients required by the plants for their proper growth. It also improves the water-holding capacity of the soil. Humus also provides food to earthworms, beetles, millipedes, etc. Other components. Other components of soil are as follows. Living organisms. Many bacteria, insects, and worms live in the soil. Water. Water is present in the spaces between the soil particles. This water is absorbed by plant roots. Plants do not grow without water. Air. The gaps between the soil particles are filled with air. Soil organisms and cells of roots use air for respiration. Let us perform a simple activity to show that air is present in soil. To study the various components of soil, dig up some soil from your garden and put it in a beaker. Fill the beaker 2/3 with water and stir with a glass rod. Now let the beaker stand undisturbed for about 30 to 45 minutes so that the soil settles down. Record your observations. You will observe that the largest soil particles, or gravel, will quickly sink and settle at the bottom. Above the layer of gravel will be a layer of sand particles, and above the layer of sand, you will find a layer of clay particles. Muddy water forms a layer above the clay. Lastly, right at the top, you will see a layer comprising dead and decaying organic matter mixed with froth. This is humus. By measuring the height of different layers, you can have a relative idea about the proportion of each component in the soil. Perform the same activity with soil samples from different places like a river bank, forest, playground, wasteland, etc. Record your observations in the form of a table. To show that water and air are present in soil, take some garden soil in a beaker. Cover the beaker with a petri dish and heat from below. Heat for a few minutes. Remove the covering dish and turn it over. You will see that water droplets have formed on the bottom of the dish. This confirms the presence of water in the soil. Take a potted plant and put some freshly dug up soil in the pot. Now, slowly pour some water in the fresh soil. Bubbles will be seen rising from the soil as water takes the place of the air, which escapes in the form of bubbles.